So we're in the middle of section 7.3. I'm going to do 4 examples in the middle. I'm going to go out of order, but I am going to start with example 3. Looking at example 3, it asks us to solve the equation. So here we are at example 3. We're going to solve 2 times sine of theta plus square root of 3 equals 0. You just learned about using k and finding all the potential solutions. It's kind of nice on this one where they want us to find the solutions, but they block us to just finding the solutions between 0 and 2 pi. So that's what we're going to do, and you might even put the word hey or put a little smiley face, but that's all we're going to find, no general formulas. So when you look at this, there's no need to panic or freak out, just kind of look at it like a regular equation. We're going to move the square root of 3 to both sides, and then we're going to come back and we're going to divide by that 2. So a pretty quick rearrange. Our sine theta is going to end up being a negative square root of 3 over 2. When you see this, your brain has to be aware that we are doing theta, and it's the inverse sine of this negative square root of 3 over 2. I like to do a visual. I like to see where we are. But then something happens right here. I've been telling you over and over and over about the restricted areas, and make sure you stay in the certain quadrants. And when it's sine, you make sure you stay in quadrants 1 and 4. So kind of a way I look at this is, who just put that inverse there? Did it come to us in the problem, or is it something I came up with later? And when it's something I came up with later, it's almost like the rules go out the window, sort of. But a way to differentiate is, did they start telling us that they want the inverse and they have a red marker on me? Or did I generate this in order to solve my equation? Since I generated it, it opens up the whole quadrant system. In other words, if I'm looking for the angle whose sine was negative square root of 3 over 2, sine is going to be negative either here or here. So I'm looking for this theta or this theta. And if I'm trying to find 0 to 2 pi, then that means I'm actually looking for this angle, and I'm looking for that angle. So I told you earlier that I like to go ahead and draw on these, get my stuff, my numbers, just to see a visual of what's going on. So I'm going to start here, that sine is y over my r. Since it is, I'm going to go ahead and put the negative square root of 3 here because it represents y and it's negative. My r is not going to ever be negative. It is a distance, it's a radius. I'm not going to put anything for the x. Oh, I can, because I should start to realize that I've got either a 30 or 60 degree triangle. And with the square root of 3 being across, then that puts this at a 60 degree angle. And all the way around, that would make it a 300 degree angle. I have another. I can do the same thing here, or I can probably go ahead and guess that if it was 60 over here, it's 60 over here. And in that case, I need to do my 180 plus 60. And I'm looking at 2 angles, a 240 degree angle and a 300 degree angle. And that's all I'm going to have in this restriction or boundary that they have given to us. But everything we've been doing that has involved our inverses has been in radians. And so in this case, if I know my 6, and I'm dealing with a 60 is a pi over 3, or I've already memorized that if I go around a full pi, that's 3 pi over 3s, 3 of them. And I'm going to go around another third of a pi, then that 240 is going to be 4 pi over 3. And if I go around one more pi over 3, let's throw in another one, we're at 5 pi over 3. And you can't even see me writing any of that. But that gets us to 5 pi over 3, and that's our solution set for example 3. So this is a great time for you to stop the video and to pause, think, reflect, even try to redo this example without looking at the notes. But right now I'm not going to go to example 4. I'm going to go over to example 5. Example 5 is on the next page. And example 5 at the top of this page says, hey, let's go solve this equation. This equation is tangent of some theta minus pi over 2 is worth a 1. Oh, and by the way, they have restricted us again, not doing a general formula, but we're going to stay within these boundaries. So I'm pulling this back up. I wrote down the problem here, and this one's just a little bit different. And so that's one thing that's cool and maybe not so cool about math, is that once you learn something, you can then add to what you already know. So make sure you really do understand everything we just did on example 3, and then now try this example 5 with me, because here's the question we're asking. The question we're asking is the tangent of what? And it's not just a theta now. It's a tangent of a bunch of stuff. But the tangent of what turns out to be 1. The tangent of what turns out to be 1. So again, I like to get over here and draw and think. The tangent is 1. I need to have memorized that when my tangent is 1, I am talking about a 45-degree angle on quadrant 1, in quadrant 1, or I'm talking about a 45-degree angle down here in quadrant 3, because when I have negative over negative, I end up with a positive 1 again. So either one of these places is telling me that this junk right here, inside the parentheses, it's either going to be a 45-degree angle or whatever angle it is all the way around to here. Remember, we are using radians, and so I'm going to need to talk pi over 4. So what is happening is I asked it a little differently, and I said, what tangent, or tangent of what, is 1? And we decided, well, tangent of 45. So all of this stuff in here, this theta minus pi over 2, it can be 45, but wait. Even though they have restricted us, I still need to make note that it is not just a 45-degree angle, because I'm going to be manipulating it with this stuff over here. I've got to incorporate every circle, either going clockwise or counterclockwise. I've got to incorporate all of these. But a really cool thing's going to happen on this problem, because I can say, oh yeah, I need to write the 2k pi, because not only is it this 45 right here, it's also when I go around a 2 pi, and I can do that 2k amount, like when my k is 0, when my k is negative 1. But wait, looky, looky. On this particular problem, it's going to be even better. Because if I'm at this 45 and I go a full pi, I'm at the other angle. Well, what if I went another pi? Am I back to where I start? Well, what if I go backwards a pi? Oh my goodness. I don't need 2k pi on this one. All I need is k pi. And I don't even have to mess with this other 45. Just by playing around with my first 45, it is going to encompass all of pi's going clockwise or counterclockwise. So it might be really good to stop the video, think through what we've done so far, where I said, you know, tangent of what is a positive 1. We played with it. Oh, and then it's, oh yeah, it's not just that, it's a 45. I got to think of, oh, it could be a whole lot of more terminal, the coterminal angles. Well, now that I've got that written down, I don't need theta minus pi over 2. What I need is theta. I need theta. I need to know all of the thetas between 0 and 2 pi. Well, then that just means I need to add a pi over 2 to both sides. Well, I need to go ahead and write that one as a pi over 4. And I need to add a pi over 2 to this side. Well, we end up with theta equals, well, when I put, this would be 2 pi over 4 with 1 pi over 4, I get 3 pi over 4 plus k pi's. Well, I'm going to do another drawing. because I need every one of them that fit in between 0 and 2 pi. So right here, and my paper is not cooperating, and I'm afraid I'm messing with your microphone and it's getting very loud and rude. Here we go. So looking at this, I need to play around with my 3 pi over 4. So I'm going to put a 0 in. When I put 0 in, let k be 0, I get actually 3 pi over 4. So one of my answers for my solution set is going to be 3 pi over 4. Well, what if I went back? I do negative 1 pi. What if I go back a pi? If I go back a pi, I'm going to end up back here in the negative area. So I'm not going to use the negative 1. Well, what if I use a positive 1? What if I take this and go forward a full pi? Well, that's going to put me at 4 pi over 4, 5, 6, 7 pi over 4. And that's as far as we can go, because when we do one more pi, we're going to bust past our 2 pi. We are done. And the thing I need to go back and do is to check these. I'm not going to take time for that, but I could take my 3 pi over 4 and go plug in my 3 pi over 4 here and do tangent of 3 pi over 4 minus pi over 2, and when I hit equals, by golly, it better say 1. Now that we're done with example 5, you really may want to hit pause and then come back to this. Think on it, back up, look at it, make sure you've got example 3, because now we're going to example 4. So looking at example 4. So I folded my paper. I'm having issues with my table and my document camera, but we are now at example 4. And by the way, I don't think I've mentioned the page number yet. We are in section 7.3. I'm now on page 471. And on 471, it says, let's do the sine of 2 theta, which equals 1/2. They want us to solve for all of the thetas as long as the thetas are between 2 pi and 0. I'm going to put a smiley face on that because we're not doing a general formula. We may end up using k, but we're only going to use it to calculate where we are and how much we need to keep our theta between 0 and 2 pi. So the reason I wanted to start with example 5 first is because now I think it's going to be nicer to see this one and to be able to say, so the sine of what? The sine of what ends up being 1/2? The sine of what ends up being 1/2? Well, for one thing, it's a positive 1/2. And so I need to notice that I'm at 1/2 here, and I've got a 1/2 here, so that would be 1 over 2, and this would be 1 over 2. If I'm looking for a theta or a something, maybe better if I just put a question mark, whose sine is 1/2. So when I'm looking for whose sine is 1/2, I need to note very quickly in my mind that when I'm looking at this type of triangle, I'm looking at a 30-degree angle. If it's 30 there, it's going to be 30 here, which is more accurately, it's going to be 150 degree. Well, we're not supposed to be writing them in degrees. We're supposed to be writing them in radians. So 30 is pi over 6, and 150, I went all the way around to pi, which is 6 pi over 6, and I backed off 1. So that's going to put me at 5 pi over 6. So to answer my question, what sine, or sine of what, is 1/2? Well, sine of pi over 6 is 1/2, and sine of 5 pi over 6 is 1/2. So I've got my two choices. And a while ago, it worked out kind of cute. A while ago, it worked out really cute, that all I had to do is go around a pi and a pi and a pi and a pi, and I only had to multiply in a k pi. And we were done with that and played around with it a little bit. Well, I did that one first because it was a little nicer, and I'm coming to this one after it because I'm going to need to look at when I said the sine of what is 1/2. Well, the sine of pi over 6. But it's not the sine of just theta, it's that my 2 theta needs to equal pi over 6, but a little bit more than that, because it could also be every rotation that way and this way from my pi over 6. So one set of answers can be this. Or my 2 theta, sine of what is a half, could be 5 pi over 6. And again, 5 pi over 6, I can go around 2 pi, clockwise, counterclockwise. So I've got to incorporate all of those angles too. This one's a little bit different. When we did the one a while ago, all we had to do was, we had this theta minus pi over 2, all we had to do was add pi over 2 to both sides. This one's a little bit more complicated because when I added it, all I had to do was add it to the like term. I only had to add it to pi over 4. I didn't have to mess with this k pi. They weren't like terms. These didn't have the k. So when I come over here, it's a little bit different, but no big deal. What you need to notice is that we have 2 theta. We don't want 2 theta, we want theta. So I'm going to go back over here, and what I actually need to do is divide by 2. Well, it's kind of nice here because you know what you do to one side, you need to do the other, but when we're dividing, we're actually going to need to distribute it to everyone. So this is pretty easy to see, divide by 2, divide by 2. Another way to say divide by 2 is multiply by a half. I think that'll look better on that one and be a little bit more understandable. So when I divide by 2, I get that my theta is pi over 12 plus k pi. I got to hang on to this because we're going to play around with it, and we're going to put in some different k's like -1 or 0 or 1, because remember, we got to find all of the thetas between 0 and 2 pi, and we are now sitting at theta. So here we are with one of our sets, but wait, there is another. So I'm going to do the same thing again because I'm just trying to get theta. So I'm going to divide by 2, but on this one, I'm going to use the rule that dividing by 2 is the same thing as multiplying by its reciprocal. And so here I get that theta is worth 5 pi over 12 plus k pi. Whew! This might be a great place for you to pause, go back, find where we are. Could you do this much by yourself? Play around with it and learn. It's like what we would do in class. We would stop, we would think, we would discuss. And this is definitely something that you can send me emails about and ask more questions. You also have it written out in your book, and you may like how they worded it or worked it better than what I'm doing. Use all of your resources, but we're not done with this one. We are now down to our thetas, but we now need to consider I want everything between 0 and 2 pi, so I'm going to get me another drawing. This first one is pi over 12, so about a 12th pi. So about a 12th pi, if I let my k be 0, that's going to be one of the ones in my solution set is pi over 12. It fits between 0 and 2 pi. Well, I'm also going to come back up here, and I'm going to say, well, what if my k was 1? Then that means I'll take my pi over 12, and I will cause it to go a whole pi. So this much right here would be pi over 12. Going all the way around to pi, that's actually 12 pi over 12. And so another one's going to get me 13 pi over 12. And notice where I wrote it, because I've done a few of these in my lifetime. I know that there's probably going to be one that goes here that's going to come from this one, and this one's probably also going to generate one that goes back here. The order does not really matter. It may matter in MyLab Math. I won't count off on the test if your order is not chronological. It just makes me feel better that it's chronological on my paper. So if I go one more pi, I'm going to bust through and go past 2 pi, so we are done with pi over 12. Now let's look at what we can get out of this theta. So I'm going to start with, if I had 0 for my k, then I'm at 5 pi over 12. So 5 pi over 12 is about-ish right there-ish. That lands in our 0 to 2 pi, so we have another answer. But wait, there is more. I could let this k be 1, and that's going to flick me on around to a very not straight line, but it's going to put me on around here where I'm backing off that pi over 12, And so if this was 2 pi, then that's like 24 pi over 12. And if it is, and I back off a pi, then that's going to put me at about 23 pi over 12. Now, having said all of that, I'd like to go ahead and look and see all of this crazy stuff, because I'm not feeling good about this one, and this one. Okay, let me see what I'm doing here. Oh, I see what I already did wrong. No? So what I'm doing here is rushing, and it's always good to slow down. Over here I have 5 pi over 12, and over here I just promptly wrote, oh, let's go down just a pi over 12. No, I need to go down a 5 pi over 12. And in that case, my 2 pi is still 24 pi over 12, but when I take off that 5 pi over 12, it's not 23, it's 17. I can't go backwards. My negative's going to throw me out of my 0 to 2 pi limit. And so what I notice is that I'm done. But I'm not done. I'm still going on this video. So we've done example 3, example 5, example 4, and now I'm going to do one more. And the example I want to do is example 6. And so as we look here, I'm at example, you can't see me writing, I'm at example 6. I'm on page 472, and it says use a calculator. Everything we've been doing up to here has wanted exact. They didn't say round it, they said give us the answers, and we needed to give them in radians. Now it wants them in radians, but it says let us take this tangent theta, which is equal to -2. Again, they're going to block us down so we don't have to do a general formula for the whole entire world of answers. It says express our answer in radians, 2 decimal places, and so here we go. So what we're asking is we want to know the theta where the inverse tangent is worth a -2. Again, I'll bring back what I said earlier. We started not with an inverse. So they didn't hand us an inverse. Who decided to write this? I did. And when I decide to write it, you're not going to see me say, oh, and everyone remember that when we're dealing with tangent, we have to make sure that we are restricted to quadrants 1 and 4. It's really easy to be confused right here about, well, sometimes she tells me to use it, and sometimes she tells me not to. And one of the easiest things I think in my brain is that they didn't start us off by saying, you go do inverses. They said, please solve this. I'm the one that put that down. And when I put that down, that means the whole quadrant system is fair game for finding out where are all of these inverse tangents going to be in -2 that are between 0 and 2 pi. So having said that, I'm going to start with the fact that we're doing a tangent that's negative. Tangent's going to be negative when one of its parts, the y or the x, are negative. Not both negative, not both positive. So that's going to put us down here. Or it's going to put us up here. So let me start down here. That if I do have a -2, it's a -2 over 1, and I put the negative where I need it. Since it's y over x, it conveniently falls that my -2 does go with my y because it's in the negative part of the quadrant, and my 1 goes with the x. Same thing's going to happen over here. I think, no, this is going to be y over x, and y over x over here, I need my 2 positive and my y negative. No big deal. I just need to label appropriately. And when I look at this, it does not remind me of anything cute. It's not a 30, 60, 90. It's not a quadrantal. It's like, ugh. It's nobody that I know that's cute. So I'm glad that they have said, I'm going to use my calculator and I'm going to round it. So with this in mind, that I've got a couple of places that I could have some angles. I can have an angle that goes all the way to here, and I can have an angle that goes all the way to here. But before I grab my calculator and start punching in some numbers, I want to look at one more thing. Even though we get an answer on a calculator, it might not be the one that's in the boundary, and it might not be the only answer, because now I'm not blocked by, oh, you can only keep it in the first and fourth quadrants. So let us think before we take off and start solving this. It's pretty simple to know that 0 radians over here is 0. But I want you to go ahead and punch in a little bit of numbers with me, and I want you to go ahead and punch in right here, pi over 2. And so I'm going to go grab my calculator, and I'm just going to turn it on, and then hit clear a bunch. And I'm going to hit pi, and I want to divide it by 2. And when I divide it by 2, I get about-ish 1.57-ish, and I want to go ahead and write that when I start punching buttons in a minute for this -2, the inverse of tangent, I got to be aware that from here to here is 0 to 1.57. Okay. Well, I also need to be aware that right over here is called pi, and that's about-ish 3.14-ish. Okay. Well, I know if I get all the way around here, 2 pi's is going to be about, well, I shouldn't just say we know. I should go ahead and do clear, 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 and do 2 times pi, and we get about-ish 6.28-ish. Okay. But there's one more. Down at the bottom is 3 pi over 2. With our 3 pi over 2, I'm going to go ahead and punch in to see about-ish what that is-ish. 3 times pi, I'll go ahead and hit equals, divide it by 2 and hit equals, it's about 4.71-ish. So anything down here is going to be about 4.71-ish, and I see my boundaries, my numbers, my information in radians. Okay, now I'm ready to punch. And so I'm ready to punch. I need to make sure I am still in radians or my world comes tumbling down. And I'm going to go do second tangent. I'm going to tell it I want to do it for a -2, and I'm going to hit equals. Looky, looky, looky. We got a -1.1. Woo-hoo-hoo. So one thing my theta is or can be is a -1. Let's go ahead and call it 11. So yay, I'm done, right? Wrong. It's a -1.11, which means it would have gone, oh wait, let's see for a second. If from here to here would be 1.57, that would be a 1.11-ish going the positive way, but I'm going to -1.1-ish. Don't know why I'm drawing it so far out. I've got a -1.1-ish going this way. That's not what they've asked me to find. They said between 0 and 2 pi. So it's a great number, and I'm going to use that number, but that is not going to be my final answer. My final answer is going to be revolving off of, when I go to here, I need to do pi and back off. And when I go all the way around to here, I need to do 2 pi and back off. So what am I saying? Let's find this first one, and I've run out of colors. So the first one that I can find is, this is going to be one of my angles. And that 1.11 is really important, but that 1.11 is this piece here or this piece here, and that's not my final answer. I've got to take pi and back off this 1.11, and then I'm going to have my answer. So for one of my answers, I'm going to take 1 pi and back off my 1.11, and that'll get me this angle that I need. So here we go with pi minus 1.11 equals, and we get about-ish 2.03-ish. That is between 0 and 2 pi. Folks, we have a winner. But wait, there is more. So I probably have another theta that's going to be about-ish. If I'm backing off 1.11 here, this over here is 2 pi. So I'm going to need to start at my 2 pi. Back off that 1.11-ish. And so here we go, clear, clear, clear. My 2 times my pi is worth this. I'm going to back off my 1.11-ish, and I get 5.17. These are all of the possible tangents, thetas, that once we take the tangent of them, we should get -2. I'm going to go ahead and take a moment to check one of these, Because what we're saying is tangent of theta is supposed to be -2. Let's try one. So I'm going to try tangent of 5.17, and when I hit equals, by golly, it better be darn close to -2. So here goes my tangent of 5.17, and when I hit it, I get approximately -2-ish. That is close enough-ish, because I rounded this off to the 1.11. If I would have left it in my calculator, it would have been a little bit better and more accurate. But for right now, we're going to put a big smiley face. We're going to do a happy dance, and I'm going to say I am done with these 4 examples.